Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is find common characters. So let's go to LeetCode. There you go. Given a string array called words, return an array of all the characters that show up in all the strings within our words, including duplicates. So you may return the answer in any order. Alright, so basically we are given words and we need to return all the common characters that are basically among all the words that are given to us. Alright, so I've taken the first example here. We are given this list of words. So we have Bella, label, and roller. These are the words that we have. Now, how do we actually find our answers, which is returning as a list all the characters that are common among all the words. So let's say if I choose the first word as my base answer, what does it mean? It means that B, E, L, L, and A could be my best answer, right? It could be my best answer. Why? Because this at max would be I would be returning, and because I can choose any of the words and I'm choosing the first word, and at max all of these characters have to appear in other words. And if some word has a lot of characters but they are not of any use to me, because this is the minimum that I would be returning, right? Because they have to be common among all the words. So I'm choosing this as my base answer, and I'll just call it answer list. And what I'll do is now I will go to the remaining words. I will one by one I'll iterate over them and check if all these characters do exist, and that also basically there's checking in a way that like I actually record their frequency, and I know that I basically, if you create the counter of this label here, so you would know, you can actually just check. So L occurs one time, A occurs, L occurs twice, A occurs once, B occurs once, and E occurs also once. So I would just check if B exists here. Yes, it does. E exists. Yes, it does. L exists. Yes, it does. And then I will reduce its count. So I'm reducing all of their counts, but this count will still be 1. I'm just trying to tell you like there need to be a way of checking that if there are duplicates, because duplicates will be returned in my answer. If all the words have 2 L's, which in this case do, I will be returning 2 L in my answer. So here actually everything here is actually common between Bella and label. A is also common. Okay, so there is nothing will be dropped from my list. How about roller? Well, now you can see, is B present here? No, so this will be dropped from my answer. Is E present here? Yes, it is, so it will stay there. Then is L present? Yes, it is, and of course we will have to remember that we have used this L. Then another L, yes, that is also present. So these two, yes, they do. How about A? A is not present in roller, so that is why my answer would be E, L, L. So E, L, and L. So that is going to be my answer. That could be a brute force way of solving it, that you create a list and then you're trying to create another answer list by iterating over the next word, the remaining word, and then you basically only add to your list what you actually see in both the words. So if you see in this word, you create it into a list, and then if you see the same character, but remember you can modify this list that you can create. And if you want, I can just simply I'll just write the brute force solution here. Like I'll just write the pseudocode. I'll just write the pseudocode, and then we'll move on to a better approach. it's important that we go through the brute force approach. It's not just me trying to understand it, but I'm also explaining it well that we all understand it. So what I'll do is I'll create my answer. Answer would be a list. What this list contain? The first words. Okay, first words, 0th. Now what I'll do, I will go over for all the words, for all the word in words here, going from 1 to end. Okay, I'm not utilizing the first word because I'm using the 0th word as my base answer. Now what I'll do is I will convert this word to a list. So I'll just say this word list. I'll just say list of word, and the reason is like I can now I can just modify this list. So I'll just say for ch in this word list, if ch in my answer, and this is where I will be creating answer duplicate because I don't want to modify this answer right here. So if this is in my answer, that means this ch occurs in both of them. First thing I will doing is I will remove this from word list. That's what I was talking about, that you need to take care of, that if you do not compare the same word with the same duplicate. So I don't want to compare this L to this L and again this L to the same L. So I will remove this from here, right? I will remove this. So I'll just do is word list dot remove. I can just remove it. I just need to remove one occurrence. It doesn't have to be the same occurrence. So I'll just remove the ch, and then I will add that to my answer. So answer duplicate, or you can say re-answer or something, and then append that ch. And then in the end, when you come out of this for loop, you will assign that to your main answer. So answer will become their answer. You could have called it new. So that will be the brute force. Here. The time complexity would be big of, let's say there are n number of words. So n into, you go over the longest word in the list. So you can call it m. M is the size of the longest word possible. So this is the time complexity and space complexity. I guess we are creating the list. So, and this list is the, you can say, maximum length of a word. Then this, these are our complexity metrics right here. Now, can we improve? Let's see if we can. Let's try to move to a more optimal, and if not optimal, definitely a simpler solution. I would say simpler solution. So what I'll do now is, since we were using even earlier the first word to create our the answer. So what I'll do is, this time I'll just say my answer map. I will try to use map this time, or dictionary, and in my answer map I will use the first, I'll just call it counter, and in order to represent that I will just even simply show the dictionary. So B occurs once, E occurs once, L occurs twice, and A occurs once. This is my answer map. I'm utilizing the first word. Now I will iterate over all these words, but what I'll do is I'll create their map as well, and then I will modify answer map such that, first of all, that key needs to exist in both the map. So I'll just call it, so for, I will just write the, so for, let's say, word in word map, in words, and we can start at 1. So this word map that I'm creating, word map counter this word, this will give me the frequency of all the words, right? So now I can just go over all the character in this word. So for, let's say, ch in this word, and in my if this ch in answer map, then I will modify this answer map ch will be, actually I want to write it right here because this is a really important line. So it will be the minimum of whatever the value I have in my answer map, that is answer map ch. So let's say ch, or word map ch. The reason is let's say I was going over let's say here in the Bella I had one more b. Okay, I had one more b. So here the count of b would be 2. Okay, now when I was basically going over label and I came across b, then here, although there are like 2 b's in Babella, but here in label it's just 1. So the max common words between label and Babella is just 1b. So that is why I'm choosing the minimum of these two values. All right, these two values. So that is why this was one of the key line code. So, and in the end, what we'll do is we'll iterate over our answer map, iterate over this, and then I would say just, you know, take the character, take the key, multiply it with append it to the answer like, okay, you know what, I'll just write it right here. I'll move this thing a little bit to this side. Here in my answer map, let's say in the end what I come across is this b1 c1 l twice a once. This is my final. By the way, this will be converted to this. So what I'll do is I will iterate over my map and then I will just append it to my answer. So b once, so b, c once, and then l twice, ll, and then a here. But remember when you will be iterating over this L roller, these will also, you know, become to 0. First of all, these will be deleted, or they will become 0. Okay. And I think, yeah, we don't have to yeah, so how would you remove the keywords that are already there but they do not occur in my word map? So I think we will have an else case here. Else case will remove we can just delete. If in else case I will just delete a character. Do I have to delete it actually? So rather than visiting in Word, I would actually visit in answer map, and then I will basically remove if that character is not in my word map. Let me show you in the code. I have not solved it yet, so I'm just, but I guess that will work, what we just discussed. So what I said is, first we have created answer map. This is the answer map, and in my answer map I have the counter words 0th. Then I'm visiting for word in words. Word map will be counter this word. Then what I want to do now is I want to visit let's say I want to visit all the keys in my answer map. So what I'll do is for key in answer map dot keys, and if key not in this word map, if this is not here in word map, then I will just delete it from my answer. But I would actually consider not deleting it, because I'm actually right now visiting all the keys. So what I will do is I will just say keys. I will store it into a variable here, and then I will visit all these keys. So for key in keys, character in keys, if this key not in word map, then it deserves to actually be deleted from my answer map. So I'll just call it key. Okay, so the reason is I must have added to my answer map from the first word, but that character does not exist in my current word that we are going over here, because it does not exist in my word map here. So what I'll do it, I'll just delete it. I'll just delete it. Otherwise I will update my answer map. That particular key, because it does exist in both, by minimum of answer map key, this value, or you can say word map, because it does exist in both of them. So word map key. All right, and then finally we will actually just go over our answer map again. This will be a modified answer map, and I will just call it result is empty for key and val in answer map dot items, and then I can just say for how many number of times for I in range val, it's an integer value, I will just append rest.append that key, which is that character. So that many number of times we are adding it to our result, and finally we'll be just returning results. Let me just zoom out and let's check it on our example cases. Let's run it. Syntax error, because this is keys and not just key, and these are not like keys. Answer map dot keys, why doesn't it work? Get the keys of a map in Python. Yeah, this works. Do I have it? Could have worked, but does it not work in the counter? That's weird. Oh my god. My brain. Okay, never mind. So is it because of I have this as keys, let's say chars, and this chars here gives you, I guess, a list, right? So let's say chars, and this I just convert it to a list and then run it. Now tell me, yes, it does work. So let's try to submit it. Great, now we can write our answer. So this is what I was talking about, like when we were on the conceptual part, rather than going over the word, you visit the characters inside our answer map so that you can actually delete those, the one that do not occur in the word. I hope you're getting it. Okay, so I will just write down the time complexity, which is big of n. That is the number of words, and for that word I go over the frequency again to check in the answer map. So let's say that is the size, the longest this maximum I'm just considering L. L is the length of our answer, the number of unique characters that are shared, right? Or initially it could start with the longest word, because in the beginning you will store everything inside your answer map. And then space complexity would be this answer map big of L. L is the size of the longest word. Okay, so that is all. Let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem.